Let's try the next three questions. So 62, 64 and 66. Pause the video, try first, and we'll go through it together. Alright, the first question is asking you to work done by this force. So it said there's a force which is not constant. You can see from the graph, it's changing somehow, it's increasing, constant, and decreasing, like with different values. So there's no way you can apply the equation of work done equals to Fs, because if you just do this like without integration, then this one you have to have the force to be a constant. So in this case you cannot use this equation. The other way to do it in this question obviously is to try to find out the area, because again this is the definition of work done. So finding out the area is just the trapezoid area, so you can find the point here, and you should be able to find out the length here should be 7 and the base is 15 and the height is 8, so you can find the area and find 88 joule for the work done. So this would be an expression that I would like to see, writing down that work done is the area under the line. So this actually is quite important to illustrate to the exam marker that you understand this relationship. For B is actually very simple, because this is already the force accelerating the objects. Then obviously this work done will eventually transform into KE. So then you can write the relationship of this, and since it was at rest, so that's all the KE that you have, and just fill in the substitute what you know, and you find the final answer. So this one is very easy. I think the best part of this question is part A. Alright, next question. So this question is very simple. You just have to use the idea of the equation that we proved in the first video, that is power equals to force times velocity. So here you just have to pay attention to one thing, because the unit that we use for this equation obviously is watts for power. Watts is joule per second, by the way. Force has to be Newton, and velocity has to be meter per second. So this is the SI unit we have to use. And if you look at this, this is in km per hour. So one thing that you must do is to convert it from km per hour to meter per second in order to substitute into V and find the force in Newton. And if you are able to do that, you should be able to find 100 km per hour equals to 360 meter per second. If you don't know how to do it, let me just show you very quickly. If you never know how to convert a unit like this in this way, like how it's equivalent to, then you have to think about this. Km per hour is like this, right? 1 km divide 1 hour. Just think about this way first. And then you want to convert something that you want to convert right on the right hand side, so meter per second. So the first thing you have to think about is 1 km equal to how many meters, so that will be 1000, and 1 hour equal to how many seconds, and that will be 60 times 60, right? Because 60 minutes and 60 seconds. So in this case you will find out that it would be able to find out the equivalent, but then if eventually you want to find not 1 km per hour but 100 km per hour, right? So on both sides of these you have to times 100, just like what you do in primary when you learn about equation. You can multiply, you add something, whatever you like on both sides of the equation. So in this case you'll be able to find the equivalent of 100 km per hour will be 360 meter per second if you try to use the calculator to calculate this. So after you get this done, then everything will be easy. So power will be 90,000 and force is the unknown. V will be 360 and so you can find the force 250 Newton. Alright, the last question here is that there is a motor which will lift up 50 kg for 50 meter in that much of time, and ask you to calculate the power necessary for this. So I think quite straightforwardly you can find the power equals to energy over time, and energy here obviously would be the GPE, and therefore you put down mgh for that to evaluate how much energy will be, divided by the time, substitute everything inside, you actually can find the answer to be 60 watts. Alright, for part A. For part B, it said the power supply is actually 80 watts, so to calculate the efficiency of it. So just to recall the efficiency equation, which obviously you learned in IGCSE already, it will be useful power or energy of the output over the total power energy or power. It really depends on which one you say. It's both are fine, and then times 100%, and obviously 60 divide 80, the unit will cancel off a watt, and so the answer is 75%. For part C, it says the motor is now used to rise a load of 100 kg with the same distance. So you may want to notice that it was 50, but now it is 100 kg. So the efficiency remain unchanged. How long does it take? So by just looking at the equation, actually you can look at this one. What you can say about is the power remain the same. So I'll put a cross here, means it remains the same because efficiency is the same. And so mass would increase by 2, G doesn't change, H doesn't change, and therefore T, the time, has to increase to balance the whole equation, and you have to increase it by 2 times as well. So that's why the answer is 2 times longer to take the whole mass to the same position. Here is just an illustration of the Sankey diagram that you could draw. That was from the motor. It was the chemical energy, where it can provide you 80 joule maybe in 1 second, and 60 joule of it went for GPE, and the rest of them you can think about what they are, and that would be thermal energy or sound energy mostly.